Now live. Great. So the first thing I'm going to do is I'm going to click this button here, all right, to run all the code blocks above it. Does everybody see that? I'm going to click on that. It's just going to run all the blocks above, which is super handy so that I don't have to go through the individual chunks and run them one by one. Next, it says, draw a map of the US with the 4 colleges I've worked at. All right, so let's just copy, paste, and tweak the code that's already there, folks. This is such a simpler approach. Take code that you know that works and then change it. So here we go. Here is the map of the US that we load from the maps package, and then we convert it to an SF package object. I'm going to paste that down here. So I'll load that, all right? We don't need the plot of the original map. We're interested in the SF object. And live coding, all right? What is it? ggplot plus geom SF data equals USA SF. Let's run that. Okay, great. That's the starting point. We've got that working. Let's now layer on the points. BERT colleges. These are the colleges that I've worked at. But remember, folks, BERT colleges is not an SF object. It's just a regular data frame. So what do we need to do? We need to convert it to an SF object. Are there any questions? How do we convert it to an SF object? Well, let's take the same code that we used for Hillary Clinton and Trump and use that part of code that we know works. Let's go down here. What is it? Let's call it BERT colleges underscore SF is equal to BERT colleges pipe that. But oh snap, check it out, folks. The order of this matters. Kind of like longitude is an x coordinate and latitude is a y coordinate, all right? We have to use longitude first. And where's the longitude? It's LON. So I'm going to change this to LON and run that. In fact, you know what? I'm going to move this here to be organized. I run that. And then what can we do? We add that layer. geom SF data equals BERT colleges SF. Paste that there. Great, the points are there. But now let's layer on some more complexity. Let's make this look a little bit better. First of all, the points are kind of small. So why don't I make them bigger? Size equals to 3. I don't know, let's do that. Highlight that, Command Enter. Okay, that's a little bit better. But now, wouldn't it be cool if we had a legend for these points? How are we going to do that? We can map the cities to color. How do we do that? We already know how to do that in ggplot. AES col equals name. I'll highlight that. Only that part. Run that part. Boom. Any questions? Right here.
Is there a way to like jitter the points so that we don't get Amherst and Smith right on top of each other?
Ooh, you know what? I'm sure there is, like a geom jitter SF. We can try Googling it. You know what? Let me just do a quick Google search here. Geom SF jitter points. It looks like, yes, there is an ST jitter function that you can use. Because I agree, at this point here, Smith is layered on top of Amherst College, not because they're so close relative to the scale of the entire United States. All right, anybody else have questions? All right, I'll share this code on the web page after today's lecture. But now, let's do the Map of Massachusetts. All right. So again, live coding. First of all, I'm going to copy and paste this code that creates a data frame of colleges, but now I'm going to replace them with cities in Massachusetts. Let's focus on only 2 instead of 4. So I'll just clean this up right now so that it's only 4 of them. All right. All right. So it's nice and clean, only 2. Could somebody name me one city in Massachusetts that they plotted and the coordinates? Right here? Boston. Okay, so I'm going to replace that with Boston. What's the latitude?
42.3601.
Okay, and what's the longitude?
-71.0589.
Okay, and can somebody name another city?
Worcester.
Worcester. Again, folks, pronounce Worcester. For all the international students, it's not Worcester, it's Worcester. All right, what's the latitude?
42.2626.
2626. Negative?
-71.8023.
8023. All right. And we know what? We'll call this MA cities. Okay, so folks, how did we do that? Well, we found them on Google, all right? We did this manually. So, like before, MA cities is just a regular data frame. So let's now convert it to MA cities SF, which is MA cities pipe. And again, folks, if you have code that works, just recycle it. Great. We now have an SF object of those cities. Let's go here. I'm going to take this plot that I know works, and I'm going to switch out Burt College's SF for MA Cities SF. Okay, great. The map works, but it's for the entire United States. We don't want it for the entire United States. We only want it for Massachusetts. So watch what we're going to do. Take a look at USASF. USASF it has all this metadata, but otherwise it's just a data frame. It is a simple feature collection with 49 rows, all right, and the following variables. So what can we do? We'll do MASF is equal to USASF filter. ID is equal to, and all right, we got to practice spelling. What is it? MASSASCHUSETTS. Great. I'm going to run this line here, and then I'm going to switch out MA.SF. Nice and clean. All right, folks. More important than the actual result, did you see how I sort of built it up slowly? I took code that I knew worked, recycled it, changed it little by little, and built it up slowly. I want you all to take that same approach for your mini project 3. Okay? Questions? All right, let me stop this recording.